Alright, so in this lesson we are going to make sure we can write on this. In this lesson we're going to solve for unknowns of trapezoids by using the trapezoid mid-segment theorem. So, trapezoid. Let's figure out what a trapezoid is first. So, as you can tell, 4 sides, right? And, I mean, pretty much it. I mean, special ones are rectangles, squares, parallelograms, like rhombus, I guess rhombi. And so we'll be looking at these ones right here, but know that these technically are like trapezoids. They're just like special trapezoids. So trapezoids, polygon, 4 sides, different types. So, properties of trapezoids. So, you'll notice that there are 2 parallel lines. So, parallel, a parallel. So, AD is parallel to BC. Okay, so, and AD in this one, well, let's do that first. Yeah, AD and BC are actually bases of our trapezoid. You can think about that as they can sit, like if it's parallel and it can just like sit on the ground. I'll put the ground here. The ground. Sit on the ground. I guess I could write that a tiny bit nicer. Ground. Or the floor. Technically, you could like put the AD down here and the BC up here, look upside down, but it's fine either way. And these are called legs. So in ours, AB and DC are legs. Okay? I don't know why, but that bothers me. Okay, equals legs. They both are legs. So, isosceles trapezoids. So, for example, let's say let's label this A, B, C, D. Isosceles trapezoids are ones where when the leg right here meets the base right here. So I'll just say 2 pairs. In this case, we have 2 pairs of congruent angles. 2 pairs of congruent angles. 2 pairs of congruent angle. I can do this. Of congruent angles. Okay. So for instance, BAD, so angle BAD right here is congruent to angle CDA. And angle ABC is congruent to, so ABC is congruent to DCB, angle DCB. They're too far away from each other. DCB. So BAD is congruent to CDA. And ABC, angle ABC is congruent to DCB. Also, do know that these 2 little angles this isn't an angle bisector, so this is not congruent to this. Like this part is not congruent to this angle. This angle BAC is not congruent to CAD. And over here either. And here and here. These are not bisectors. So these are called diagonals. Which you know, but these are the diagonals. So in the diagonals, so I guess I'll put P. So AP is congruent to PD. And BP is congruent to CP. Let's make sure I did this right. Angle B. Okay. And lastly, we have these things called mid-segments. So here's midpoint of this side, and here's the midpoint of this side. Here's midpoint of M, and here's a midpoint. Here's midpoint M, and here's midpoint N. So M is a midpoint, is the midpoint of BA, and is the midpoint of CD. So in this right here, so the two bases, so base 1 and, well, base 1, let me make sure that's a little better. So the sum of both bases, so base 1 plus base 2 divided by 2 will give you the length of the mid segment. So basically, the mid segment, so the mid, I can do better than that. The mid segment is a half of base 1 plus base 2. Whichever way is helpful for you. And I'll show you what I mean. So this mid-segment is half of these two. Or these two divided by 2 will give me the mid-segment. So, example number 1. We want to figure out what x is. We can tell that this is a trapezoid. And this is a mid-segment right here. You can tell this is a mid-segment right here to here, because it cuts both sides like in half, right? Like this is the same as this is the same like this. These lengths are congruent, these lengths are congruent. So we know we have two options. We could say that the two bases together divided by 2, we actually have more than two options, but will give me x, which will be the easiest one to do. You could also just say that 2 times x, oh, no, that's incorrect. We could also say that x is half of base 1 plus base 2, so 18 plus 48. Whichever you prefer, it doesn't matter. I like this one. So 18 plus 48. So 40, that's 50, and then 16, so that's 66 divided by 2 is x. That means x is, let's correct that 66. Looking a little dreadful there. 66 divided by 2 equals x. We get x is 33 units. Okay. And over here, you could do the same. I mean, you would just get 66, and then you have to multiply it by half. And then you get x equals the same thing, right? Let's do a slightly more difficult one. So, example 2, we have a trapezoid, mid-segment. You can tell because that's in half, joined together. So, x plus 3, I guess I'll put it in parentheses, plus 4x plus 7 will equal, divided by 2, will give me 15, it looks like. So just like any other thing, like any other equation, when you have like a fraction, I just like to get rid of it. So I'm going to multiply both sides of my equation by 2, like this. And that will go away. So I end up with x plus 3. I'm going to get rid of these parentheses. They're sort of useless. Plus, because, you know, if you add this, you're just adding it. Like, if you add a bunch of positives, yeah, you get what I'm saying. Should equal, so I'm going to do this first. I forgot to do this. You're multiplying this by the whole thing. Anyways, you understand what I mean? And 15 times 2 is 30, and we get 5x plus 10 equals 30. Let's subtract 10, subtract 10, 5x equals 20, divide by 5, x equals 4. Remember, this isn't units because we have to plug it in to see it. So if if it asked for this length, you would have to like plug this in, like substitute in here or substitute in here. But in this case, it doesn't. And that is it. Thank you.